Welcome. Under the supervision of Varia Foundation College, Town campus, this is chemistry class, and today we are going to study the industrial importance of equilibrium constant. Earlier, we have studied that how Kc is important in many deals. Now, we will only focus on the industrial importance. We have given with the two examples in your book. One of the examples is about Haber process, and the other is about the contact process. In the Haber process, we are making ammonia industrially, and in the contact process, we are making H2SO4 industrially. And you must have seen this various times that in the whole chapter, only these two examples industrially have been given. So we are focusing on these two things only. Obviously, you will study more in the grade 11, and the importance of equilibrium constant, the four importances of the equilibrium constant, we will study in very much detail in class first year. And obviously from so on, if you will keep going on with the chemistry as a subject, you will study huge importance regarding these 4 points which we have discussed earlier. Today we are only going to study that how ammonia and H2SO4 yield is increased by using the chemical equilibrium reactions. Number one thing is that you can see the main ingredients of both of them is oxygen and nitrogen. And we have these two things very much available in normal air. So it means that these are the two ingredients which are in a huge you can see amount, present in a huge amount when we are going to react, when we are like the availability is very like in excess, we have them being available in excess. So it means the restriction factor which is restricting the chemical reaction is the other ingredient which is used being in these chemical equations. For example, when we have to prepare ammonia, we have two ingredients, nitrogen and hydrogen. So it means hydrogen is a restricting factor. When we have to prepare H2SO4, all the other processes are important, but actually the process which is contributing in the huge yield of H2SO4, the reaction which is contributing the huge yield of H2SO4 is the reaction in which SO2 basically converts into 2SO3. And you have studied this process, and you have basically studied this reaction various times during this your course of study. So basically this reaction is very important. If for example this equilibrium reaction proceeds in a very good way, or in other words it should proceed in a forward direction as much as possible, we can yield almost 100% of the pure sulfuric acid from this reaction. Okay, after reacting this SO3 basically reacts with water, and this water produce the huge amount of SO3 produced oleum, H2S2O7. This is known as oleum. This product is on, and after the disintegration, or you can say when we heat up oleum, we can get H2SO4, and this SO4 is 100% pure. Now please consider this, because this happens as earlier as well. Students think that actually 100% of H2SO4 we are getting. No, we are not getting 100% of H2SO4. We are getting 100% pure H2SO4. H2SO4 amount is actually 99%, approximately 99.9% H2SO4 we are getting from this reaction. Now we will study the first reaction first, the Haber process. Students, what happened? This process in which hydrogen and nitrogen are reacting together, the conditions applied are the temperature, which is 400 degrees centigrade, and the pressure, which is 200 atm. Under these conditions, if for example we will just process this equation without these conditions, we can get 33% of the ammonia. But after putting these conditions, and after putting this condition, the reversible process would basically favor the production of the favor into the forward direction only, means forward direction N plus H2 gives ammonia. So after putting the conditions, we can get at least 98% of the ammonia. Is it clear? Next, for example, similarly, which I have discussed earlier, that similarly in this reaction, platinum or vanadium pentoxide is basically used, V2O5 vanadium pentoxide, which is known as, and platinum. These two catalysts are used to go on this reaction, but the conditions applied during the process of SO3 formation are the temperature, which is 450 degrees centigrade and 200 atm. After the applications of these, the equilibrium would attain at uptime where we can attain maximum amount of SO3, and as we are attaining the maximum amount of SO3, we can convert this SO3 into oleum, and from oleum we can get our sulfuric acid. So this is how the industry the chemical equilibrium, the Kc value basically describes that after putting the conditions, the pressure and the temperature, we have the fourth point which we have discussed, to predict the change in the conditions of the chemical equilibrium, about the in the change in the conditions, means pressure and the temperature. So when the pressure and the temperature is changed, we can see that how Kc was changed and how the maximum amount of the products we could attain from this reaction. So this is whole for this from this topic. I hope you would able to understand it, and I have tried my level best to produce a smaller video so that we could get this video onto the WhatsApp easily. So this is all from this topic. Thank you. Allah Hafiz.